Circles part 1. There's a couple formulas that we need to know for circles, right? Thanks for answering. Area. How do you find the area of a circle? Pi r squared. Circumference. How do you find the circumference of a circle? 2 pi r. We will also talk about, what do you call them? Sector area. Remember the pi piece thing? That'll be back here, as well as arc length. So we'll talk about those on the back side. All right. Find the circumference of each circle. Use your calculator's value of pi. As soon as it says that, that means they're okay with decimal. So if I have the radius, circumference is just going to be 2 times pi times the radius, which is 10. So let's see. 2 times pi times 10. 62 point, what do they want me to round it out to? Round to the nearest tenth, so that's 1 digit, so there's the 8. 3 means it's going to stay an 8, so I'm going to call it 62.8 feet. I do not call it feet squared. Feet squared would be when we're doing area. Feet cubed would be volume, and that would be a sphere. All right, number 2. Again, they give me the radius, so it's just going to be 2 times pi times 2. So 2 times pi times 2 gives me 12 point, what is 5, 6 going to round off to? 6. And this time we're talking about meters. Okay. All right, now area. So we're going to use our area formula right here. So I need pi times r squared. Now this one, they don't give me the radius, they give me the diameter. So what's the radius? 2 and 2. So I'm going to do pi times 2 squared. Still using the calculator's value of pi. So pi times 2 squared. And rounding to the nearest tenth still, that's 12.5 what? 12.56. I'm actually going to call that 12.6. And what am I going to label this as? Because we're finding area. Yards squared. All right, over here, again, they gave me the diameter. What's the radius then? 11. So my area is going to be pi times 11 squared. So pi times 11 squared is 380.1 inches squared. Now, there's 2 problems that I almost missed here. There is a problem squished in here. It just doesn't have a picture. You see that? So if the diameter is 24, the radius is 12. So to find the area, I would do pi times 12 squared. So pi times 12 squared. Let's see. 452 point what? It says 38, so it round off to 4. And what am I going to call that one? Kilometers squared. And this one, the diameter is 10, so what does that mean about the radius?
5.
It's 5. So I do pi times 5 squared. Pi times 5 squared is 78.53, would just be 0.5. And again, I have kilometers squared here. Okay? So you will be given these formulas on there on the final. I just won't tell you which one's area and which one's circumference. You just have to be able to identify that. I always remember area is always labeled as like inches squared, so it's the formula that has the squared in it. That helps me. If it helps you, great. If not, figure something else out. All right, find the measure of the arc or central angle indicated. Assume that lines which appear to be diameters are actual diameters. So I need to find the measure of arc, RQT. RQT, that's this guy right there, isn't it? So it's going to be 78 plus whatever this arc is, plus whatever this arc is, right? So let's see what we've got here. We've got 78, and I think I can see a diameter. Do you see that UR is a diameter? So if this is 78, can't I figure out this? Because both of them together are going to equal 180, right? So 180 minus 78 is 102. So that one's 102. Can I use the same method to find this guy? If I know that one is 102, don't these together have to equal 180? So it's going to be 78. Is there another way I could have found that 78? These two are vertical angles, aren't they? So the arcs would be the same as well. So how am I going to find RQT? I'm going to take 78 plus 102 plus 78. Let's see what that gives me. 78 plus 102 plus 78 is 258 degrees. Back in business. Okay, so let's see. We need arc CEG. CEG. So we're talking about this big guy here. Yeah? Now, if this is 46 and this is 41, do you see that these three together would be 180? 46 plus whatever this is plus 41. So I'm going to take 180 and subtract 46 and subtract 41, and what's left over, 93, will be this guy right here. Okay. Are there other ways you could do this? Absolutely. For example, one thing I just noticed, if this is a diameter, I could find the measure of this arc, and if I know this, and this is the only part that's not in the arc I'm looking for, I could subtract it from 360, right? But I'm going to add, because it's what I'm good at. So let's see, 46, so let's see. This one I'm going to do the same way. All three of these arcs, 1, 2, 3, equal 180. So to find that missing one, I'm going to do 180 minus 93 minus 41, and that leaves me with 46 right here. So now I can find the measure of arc CEG by adding up all of those measurements. 46 plus 93 plus 41 plus 46 gives me 226 degrees. Okay? Questions? All right, find the measure of the arc or angle indicated. So it looks like I'm trying to find this angle right there. That's what we call an inscribed angle because the angle itself is on the circle. And that means that this arc is going to be related how to this angle? It's double. So if the angle is 50, the arc is 100. Okay? So if I can find that arc, I'm good to go. Can I find that arc? Well, that arc makes up this portion of the circle, correct? Don't I know the rest of the circle? I know this is 68 and this is 170. So how could I find out this portion? 360 minus 170 minus 68, and that leaves 122 degrees for that arc. If that arc is 122 degrees, do you see how it's the intercepted arc of this angle? Do you see that? So that means it's going to be divided by 2 to get the angle. The angle is 61 degrees. Questions on that one? Okay. All right, same dealio here. There's my angle. So if I can find this arc, all I need to do is cut it in half to find the angle. How can I find that arc? Well, this says that's the center, therefore this is a diameter. What do I know about these two arcs? They're going to add to 180. So if one of them is 108, what's the other one? 72 degrees. So I just need to cut 72 in half. What is half of 72? 36 degrees is my angle there. All right, here's my angle. Let's see what we do here. So let's see, I need this arc so I can cut it in half. If I know this one is 82 and I know this one is 198, how can I find this one? Subtract it from 360 because the whole circle is made up of those three. So 360 minus 82 minus 198 is 80. So if that's 80, what's the angle? 40 degrees. So all of these are those inscribed angles. All right, and finally, we've got this guy right here. What is the intersected arc here? Looks like this is the arc. So if I can find this arc, I cut it in half to get that angle, right? So let's see. I know a couple things. If this angle is 45, what is its intersected arc? Wouldn't it make up the arc KL? So if this is 45, KL is 90. What do I know about KL and KJ? If that goes through the center, they're going to equal 180. So if one is 90, what's the other one? Also 90, because 90 and 90 is 180. So if this is 90, how do I find the angle? Cut it in half, and I have another 45-degree angle. Okay? Questions? All right, find the measure of the arc or angle indicated. Assume that lines which appear tangent are tangent. We don't have any tangents here, but I have an inscribed angle, just like we were talking about. This time I'm looking for the arc. So if I have the angle, what do I do to it to get to the arc? Multiply it by 2. So 2 times 55 means the arc is 110 degrees. Okay? This one I have a tangent line, and I have a secant right there. They tell me the angle. What do I know about this arc? Does anyone remember that rule? That one is also double the angle. So I take 41, multiply it by 2. That means the arc from B to A is 82 degrees. If I have a tangent line to a circle, and I have a secant right there, and it makes an angle, the arc that's inside that angle here is equal to twice the angle measure itself. So if I know the angle, I double it to get the arc. If I know the arc, I cut it in half to get the angle. Okay? All right, arc length. This is another formula. Now, arc length, is that a portion of the circumference or a portion of the area? It's a portion of the circumference. So you're going to put the degree measure over 360 and then multiply it by your circumference formula, which is 2 pi r. So what's the measure of the arc we're looking at? 120 over 360. And we're going to multiply that by 2 pi r. 2 times pi times 6. Now, they don't tell me whether to use my calculator's version of pi or anything like that, so I don't know whether it's to be a decimal. So I'm going to go ahead and leave it in terms of pi just to get us some practice on that. I know it's your favorite. So 120 over 360 gives me 1/3. So I have 1/3. And what do I get in here? 2 times 6 is 12 pi. What's 1/3 times 12? 4. So my answer is 4 pi kilometers. Is it kilometers squared? No, because it's a portion of your circumference, which is just a measurement, not your area. All right, same formula over here. The measure of the arc is 90 degrees because we have a central angle that's 90 degrees, so the arc is also 90. Over 360 times 2 times pi. What's my radius? Radius? 12. So 90 over 360, what does that reduce to? 90 over 360 reduces to 1/4. 2 times 12 is 24 pi. And what is 1/4 times 24? 6. So my answer here is 6 pi centimeters. Okay, questions there? All right, I'm actually going to jump down to here, and then I'll go back to 17 and 18 because this is the area of each sector. So it's almost exactly the same formula. You're still going to take the measure and divide it by 360, but you're not going to multiply it by the circumference formula. What are you going to multiply it by? The area formula, so pi r squared. So 120 over 360 times pi times, what's my radius? 15 squared. Again, let's go ahead and leave this in terms of pi. So 120 over, actually let me use this button, over 360 is still 1/3. And what's 15 squared? 225 pi. So what's 225 times 1/3 gives me 75 pi. And how am I going to label my answer here? Feet squared, because anytime you're talking about area, you're talking about squared. Area of the sector, we're talking about the area of the pie piece. Okay? All right, next one. We got a huge pie. We got somebody who's very hungry eating more than half of it. So, same formula, 225 over 360 times pi times r. What's my r here? 3, and that's 3 squared. So, 225 over 360 reduces to 5/8 times pi times 3 squared. That would be 9 pi. How do I multiply 5/8 times 9? Well, 5/8 is on my calculator. I can just press times 9, and it gives me a mixed number. So let me change that to an improper fraction, and I have 45 over 8, and I'm not sure on your test. Usually they'll put the pi on the top. They might put it next to it. It will not be with the 8, though. It will either be next to the fraction or it will be with the numerator. Okay? All right, last two problems. Determine if line AB is tangent to the circle. Does anyone remember what it means if this is tangent, what it means for this triangle? It's a right triangle. This would be a right angle if it was tangent. So how can I see, is this indeed a right triangle? Pythagorean theorem. If it works out with the Pythagorean theorem, it is a right triangle, and therefore that is tangent. If it doesn't work out, it's not tangent. So I'm going to see, does 16 squared plus 12 squared equal 20 squared? So 16 squared is 256. 12 squared is 144. Does anyone know what 20 squared is? 400. Does 256 plus 144 equal to 400? It does. So what does that mean? Pythagorean theorem worked, so it is a right triangle, meaning this is a right angle, so yes, it is tangent. Okay. What about this one? I'm looking to see if that's a right angle. So I'm going to set 12.4 squared plus 9.3 squared equal to, what's the hypotenuse here? Because they only tell me this measure of the hypotenuse. What is this measure? No? It's 9.3 because isn't it a radius? And a radius is always a radius, right? So what is the total hypotenuse? 6.2 plus 9.3, 15.5. So I want to see, does this equal 15.5 squared? So let's see, 12.4 squared plus 9.3 squared gives me 240.25. Does that equal 15.5 squared? Sure does. What does that tell me? What did I just prove? Yes, it is tangent. Okay? Again, if the Pythagorean theorem didn't work, that means it's not a right triangle and it is not tangent. Okay? All right. Happy studying.